Well, see, whenever you talk about the reciprocal function, the first thing that comes to our mind is that what exactly is the reciprocal function? Now, first thing is that, let's say, when you talk about a function, its reciprocal is referred as 1 upon the function. Now, when your original graph is actually x comma y, the reciprocal function will have a mapping as x comma 1 over y. Now, what simply means is that for whatever the x values you have, the same y values gets reciprocal. Now, for example, if a point is 2 comma 3 on the original function, it is going to become 2 comma 1/3 on its reciprocal function. Now, one of the interesting fact that you will notice is that if I create a table for, let's say, x and y, or you can say f of x function, and then I try to create 1 upon f of x. So let's say I take x values at -3, -2, -1. These are some of the hypothetical random values that I'm taking. Let's say 0, 1, 2, and 3. And I'm taking the y values as, let's say, 5, -3. Let's say here is 0. At this point is 0.001. At this point is, let's say, 1000. Here y value is, let's say, 1. And here is, let's say, -2. Now, when you now will go to sketch these functions, these points on the reciprocal graph, now you'll have same x coordinate, but the y coordinate will be 1 upon 5 now. This is going to be 1 upon -3. This is going to be 1 upon 0, 1 upon 0.001, 1 upon 1000, 1 upon 1, and 1 upon -2. So the 1 upon 5 is obviously, like, you can see that this is fine, -3 comma 1 over 5. Then it will be -2 comma or -1 over 3. Then you'll have -1 comma undefined. 1 over 0 is undefined. So we'll talk about these inferences in a bit. This will be 0 comma 1000. Then you'll have basically the next point is 1 comma 1 over 1000. Next point is 2 comma 1. And the last point is 3 comma -half. Now, a few of the interesting observations that come to our mind is here. First thing is that if you have a root, now when you say a root means y value is 0. So where you can see y value is 0, the reciprocal of that is infinity. So when you talk about the general rules, the first rule that should be in your mind is wherever you have the roots on the original graph, that becomes a vertical asymptote. So roots become a vertical asymptote, and also vertical asymptote if there is existing. Now you can see that if wherever the y value is really large, its reciprocal is very small, which is like 0.0001. So wherever you have a vertical asymptote, that becomes roots, and wherever you have roots, that becomes the vertical asymptote. Number two is if your function is having a lower y value, like you can see that the y value is very small, its reciprocal is having a big positive number. I mean, a big value. Now, similarly, wherever your y value is 1, reciprocal is also 1. So this is something which we need to actually link it up in a solid understanding form. So some of the observations that we have to have is basically, number one, roots become vertical asymptote, and vertical asymptote, if there is on the graph, it becomes roots. Now, if you can see that there is a maximum y value, that will turn into a minimum y value. So we'll talk about this. So if there is a maximum on the graph like this, its shape for the reciprocal function will become minimum. Also, as you can see that if the function is having a positive, I mean bigger value, reciprocal is smaller. So if function actually, if the graph is increasing rightwards, reciprocal will slowly decrease towards 0. If function is increasing, let's say left towards, like suppose this is going towards positive y-axis, the reciprocal will slowly approach to x-axis. So at this will become almost a x-axis is going to become the horizontal asymptote. If there is y equals to 1 function, you can see y equals to 1 point is invariant, it doesn't change. So when you logically think of the general reciprocal function, let's take through one of the basic example that I'm talking about. So consider that I want to draw the reciprocal function y equals to x is the function. So reciprocal function will be reciprocal of this, which is 1 over x. Now, when I look at the simple point here is that if you look at the general graph, the general graph for this will be y equals to x line is here. So this is my y equals to x line. Now, when you want to sketch the reciprocal for this, now when you are sketching the reciprocal function, number one is that you have to mark where the graph has the root. So the root is at this point. So wherever you see there is a root for its reciprocal function, that is going to become a vertical asymptote. So you're going to have a vertical asymptote at the point x equals to 0. So this point that I'm marking is going to become the vertical asymptote. Number two, as you can see, the function is increasing here. The reciprocal will approach to 0, because if you can see that these y values are going towards infinity, 1 upon infinity will be close to 0, because slowly as my x is going towards the positive x side and x become large, reciprocal will slowly approach to 0. And where you can see that y values are close to 0, you can see y values are close to 0, its reciprocal will be very high. So in short, this is a vertical asymptote. And one of the important thing that you'll also notice is the function, if the function is positive, its reciprocal is also positive. So if the graph is above x-axis, its reciprocal will also be above x-axis. Now, what is interesting is that this side, you can obviously see that, visualize that the graph is going to look like this. So here you have x-axis is the horizontal asymptote now. Also, this side, you can see it is going towards negative infinity. So 1 upon negative infinity, when I take the reciprocal negative infinity, will approach to 0. So as I go this side, because if the y values are smaller and negative, reciprocal will be big positive, big negative. So it'll be from here like this, and it will come something like this. So in this simple example, you can actually see the behavior or the nature of the reciprocal function. And one of the very interesting part you notice is that where the function and its reciprocal intersect, that will be nothing but y equals to 1 line. And this will be y equals to minus 1 line. The reason is that you can see here, when I take the reciprocal of 1, it remained 1. So this point y equals to 1, wherever your y would have been 1, the reciprocal of that is going to be at 1. So from here, we can take out one of the very interesting fact is that function and its reciprocal, if at all they intersect, if at all they intersect, they will do so along y equals to 1 line or y equals to minus 1 line. So you can see that this function here at this point, they're cutting each other at y equals to 1 and y equals to minus 1 line. So let's take one more complicated example. So in the second example, when you are talking about the reciprocal function, this is actually what we are trying to sketch is the reciprocal function for 1 over, x square minus 4x. So obviously we know that the x square minus 4x graph is going to be looking like this. And when you're finding out the reciprocal function for this, we need to use the properties that we have written out here. So number one, wherever you have the roots, you identify, because these y values are 0, and if you have 1 upon 0, it become undefined, which means that the reciprocal will be having a reciprocal function will have a vertical asymptote at these roots. So when you draw the vertical line here, so these two are going to be the vertical asymptotes for the reciprocal function. So this is going to be at x equals to 4, and this is going to be at x equals to 0, because those are my two roots, if you see. Number two is a maximum becomes a minimum, and a minimum becomes a maximum. So if you see a function is like this, if its original graph is like this, its reciprocal graph will be something like a maximum. If there is a maximum already, its reciprocal will have a turning point in form of minimum. So Number one is, number two indeed is, as I said, that your, if at all the function and its reciprocal, they'll meet along y equals to 1 and y equals to -1 line. So it will be interesting to mark, let's say, approximately y equals to 1, where is y equals to 1 and y equals to -1 line. So this is y equals to 1 and this y equals to -1. So you know that the function and the reciprocal, they are going to cross at these points, because these are the points that are not changing, because reciprocal of 1 you can see is remaining as 1. Now coming back to the this point where there is a minimum, you can see there's a minimum, will become like, if this is a minimum here, it will become maximum. So function is negative, so its reciprocal has to be negative, and there are two vertical asymptotes. It means the graph has to run parallel to those vertical asymptote as well. So this point that you notice is actually, this was x is 2, and this point now will become -1, 4, because reciprocal of -4 is -1, 4. Now when you draw the graph for this part, it will be something like this. In this case, it is here. So as you can see that this rule, there was a minimum, it became like a maximum. But be mindful that if your function is having a minimum value of, let's say, y equals to -4, its reciprocal will be, maximum will have at y equals to -1, 4. So just the reciprocal value. And of course, you can see that how I'm using these 2 points is just to make my graph more accurate. Okay, now we're done for this between 0 to 4. Now let us talk in the right branch. Now, as you can see, the function is approaching to 0. Reciprocal will be having infinite value, and obviously it has to pass through like this. It is going to cross this y equals to 1. The function and the original graph will meet at y equals to 1. And because going towards infinity, reciprocal will slowly approach to 0. It will not go below x-axis. Remember that. If the function is positive, its reciprocal will be also positive. Now this side, so we're done with for this domain and this domain, and now we are doing for this one. So as you can see, the graph is going towards this side, increasing. The reciprocal function, which will be here, will come slowly approaching to 0. That is going to be the horizontal asymptote. So this is going to be y equals to 0 line. So number one, you can see y equals to 1 point didn't change. That is going to remain as it is. Roots became vertical asymptote. There was a minimum point that became a maximum point. So these are the ways in which you can draw an approximate graph of the reciprocal function. So now in the third example, what we have is basically, you can see the graph is touching x-axis at -3 and cuts at 4, and there's a maximum point of y equals to 1. Now, when you're sketching the reciprocal for this function, rule number one is that the roots that you have, they become the vertical asymptote. So you will have the vertical asymptote at x equals to 4 and x equals to -3. So these are the two vertical asymptotes. X equals to -3 and x equals to 4. Number two. Now you can see, now talk about each segment. Like first part is like this domain, second is this domain, and third is this domain. Now, as you can see that the function as well, it was approaching to 0, the reciprocal go towards -infinity here. So in this part, obviously you draw y equals to -1 and 1 line without forgetting, because the function and the reciprocal, they're going to cross at that point. So this is, suppose this -1, and if I draw y equals to 1 line, it is here. So that's this point, just to know that the function and the reciprocal, they're going to cross at these critical points. Now, as you can see that the function here is going towards an infinity, going towards -infinity. Reciprocal slowly approach to 0. So your graph, when you draw, it is going to approach to 0 like this. So here I don't have the space to show that this is asymptote, but it'll be like this is going towards this side. So it'll be like slowly approaching to x equals to, or means the x-axis. Now here, and obviously this is, as you can see, the y is closing to 0. So the reciprocal will be a big negative number, because these y values are all negative. So like reciprocal of negative 0.000005 will be a big number, big negative number, like maybe 10 lakhs, -10 lakhs or something like that. Similarly, if you look at this part, now here you have a maximum So you have a maximum shape that will turn into a minimum. Now, as you can see that the maximum y value is at 1, the minimum y value will also be at 1 here. So in this case, as you can see, the function is approaching to 0. Reciprocal has to approach infinity. So it'll be something like this. And it is not going to cross the vertical asymptote. So this part, the graph is like here. Now, the last part is where you can see this is once again the function is going towards, you can see negative infinity side. The reciprocal will slowly approach to 0, passing through y equals to 1 line. So this is how you draw the reciprocal for this particular question. So the first part we need to draw is the vertical asymptote. Now, when you talk about the vertical asymptote, there are 3 vertical asymptotes here, because when the roots are 0, I mean, wherever you can see the roots, that's your vertical asymptote. So that's your first point here. This is the second point, and then this is the third point. So these are the 3 vertical asymptotes for the graph. So these are the 3 vertical asymptotes. Now, after this, you draw approximately y equals to 1 line. Y equals to 1 line is here, and y equals to minus 1 line. So since y equals to minus 1 line is here. Now, after this, you are going to mark these points. These are the crucial points where your function and its reciprocal, they're going to cross each other. Now, obviously, you can see that this side, it is increasing towards infinity. So reciprocal will approach to 0, slowly approach to 0. Then here, there is a minimum point. So a reciprocal of -1 will be -1 itself. So maximum will be also at -1. So this side will be something like this. And then here you can see the maximum is at 0,4. So minimum will come at 0,14. And this side, the graph will pass like this. And here it will go upwards like this. So this is your reciprocal function for this range. Now for the last range, as you can see, this is going towards negative infinity. Reciprocal has to go towards 0. So it will go slowly approach to 0. So now when you're sketching the reciprocal for this one, what we do is first we mark the vertical asymptotes very carefully. So all the roots that you have, they become the vertical asymptotes. So you get 4 vertical asymptotes. Now remember that your graph, when you talk about the reciprocal function, it cannot ever cross these vertical asymptotes. After this, the other guiding point that can be very helpful is draw y equals to 1 line. And so you can figure out where the function and its reciprocal, they're going to cross each other. And then draw y equals to -1 line as well. So y equals to -1 line is here. So you know that your graph has to, its reciprocal graph has to cross through these points. Now let's take one range. So let's take the first range at this part, where you can see that the function is increasing towards infinity. Reciprocal will slowly approach to 0, passing through y equals to 1, and will become almost stagnant at y equals to 0. So y equals to 0 is the horizontal asymptote here. Next up is this minimum. As you know, it will become maximum. The coordinate here is at -2, so it becomes at positive half, I mean negative half. So y coordinate will be at -half, and it'll be here. Make sure do not cross the vertical asymptote. So this coordinate which will be there is at y equals to -half basically. Similarly, even for this side, there is a max. You can see there's a maximum here. So minimum value will be also 1, and it will be touch and go above x-axis like this. And in this part, you will have the graph something like this. Again, at this point will be at -half y coordinate. Now the last part is, as you can see, this is going towards positive infinity. The reciprocal slider will slowly come towards 0. So this is how you sketch the reciprocal function for this particular example. So the first thing here you notice is that in the original function itself, you have got a vertical and the horizontal asymptote. Now, when you want to sketch the reciprocal function for this, again, the rules apply. when you have the roots, like this point, which you notice is at x equals to 2 is there is a root, that's going to become the vertical asymptote for the reciprocal function. So don't forget the rules. Now, you can see that y equals to 3 is the horizontal asymptote. Now, when you have y equals to 3 as the horizontal asymptote, the reciprocal for its, I mean, y equals to 1 upon fx will have a reciprocal at y equals to 1/3. So let's say I'm assuming approximately this is y equals to 1/3. So the horizontal asymptote for the reciprocal function will become 1/3. Also, as we know that the roots become vertical asymptote, and if there is a vertical asymptote, that becomes the root. So since there's already a vertical asymptote here, that is going to become the root. It means that your graph has to pass through that point. After this, you have the normal operations, normal calculations to be done. Okay, now in this case, as you can see that this is going towards infinity, reciprocal is going towards infinity. So, I mean, the function is going towards infinity, reciprocal will be 0. And this way, if you want to draw y equals to 1, -1 line, you can draw y equals to -1 line just to figure out where are the graphs meeting each other. Here is y equals to 1 line also I'm drawing. So this is the point where you can see, take now each and every fragment separately. So like this fragment is separate, this fragment between 2 and 3 separate. Now in this case here, as you know, this is the root, it will pass through this point and it has to become asymptote at this point, vertical asymptote. So for this part, where you see this tiny little part, reciprocal for this, as you can see, will become something like this. So as you can see, this y values were approaching to 0, reciprocal approach infinity, and this one y was approaching to infinity, reciprocal approach to 0. So this part you can clearly see. Now coming back to the right hand side. Now just imagine these y values are very large, so reciprocal will be close to 0. And now the minimum that you could see was coming at 3. So reciprocal will never go above 1/3. Common sense is, if you take reciprocal of any y values which is higher than 3, it has to be below 1/3. For example, reciprocal of 12 is 1 upon 12. So if this y value is, let's say 12 here, it'll be 1 upon 12, it'll be somewhere here, and so on. So maximum it'll go up till will be 1/3. So this side, this is the asymptote, and the rationale is to draw this asymptote is because you know that this is not going to be above 1/3. So that's the half part done so far. Now coming to this side. Now here you can see this point is 0, 2. So reciprocal will be at 0, half or something here. And this side, you could see that the minimum that it attended was, maximum it attended was 3. So this side, as you can see, the y value is approaching to 0. Reciprocal will go up. It will go up here like this. And it will be asymptote at y equals to 1/3. So it will never go below y equals to 1/3, because the maximum was, the function had a maximum at 3. You could see that it was maximum as 3. Now reciprocal, its minimum will be 1/3. So that's how you draw the reciprocal, where there is already a vertical asymptote and horizontal asymptote.